Welcome to Unit 6, Geometric Vectors, Lesson 5, the last lesson of geometric vectors, resolving resolution of vectors into rectangular components. If you've taken physics, of course, you've done this many times. If you haven't, that's okay. So a vector can be resolved, that means broken apart. So resolved into two perpendicular vectors whose sum is the given vector. These two vectors are called the rectangular components. We saw a little bit of this in lesson 4 with those examples of the vectors. Frequently, vectors resolved into horizontal and vertical components as illustrated. So here's my vector. I can break it into the horizontal component, which is called VH, and then the vertical vector, which is called VV. So that means that vector V is really equal to vector VH plus vector VV. That means the horizontal component of the force can be calculated using VH. So if I have VH here, this is equal to, and again, because I have this and this, it's actually equal to, this is, again, the adjacent side, this is the opposite side, and this is the hypotenuse. Because I've got the adjacent and the hypotenuse side, I know this is really equal to the overall force times cos theta. And if I do VV, the vertical component force can be calculated using, because I'm using the opposite and hypotenuse side, so the overall force times sine of theta. These two are very important, and we'll use them quite a bit in this lesson and beyond. All right, and actually we're going to see this in the first lesson of Unit 7, Cartesian vectors. All right, let's go to example 1. A basketball player shoots a ball with a force of 150 newtons at an angle of 40 degrees to the horizontal. So here's my horizontal, and then here is my shot. So, and this is 150 newtons, magnitude, and this is my angle. It says resolve it, draw a diagram showing the resolution of the force into its rectangular components. So the rectangular components I will use my horizontal component with a purple pen. So that right there, that is my horizontal force, and then here I'll do this one in green. This is my vertical force, my FV. There we go. It says determine the magnitude of the horizontal and vertical components of the force. Of course, we don't need a direction because the horizontal force is going in a horizontal direction, the vertical force is going in a vertical direction. So this is the magnitude of the horizontal, vertical. I guess we would have to do direction because is it going left or right, or is it going up or down? But here it's just asking for the magnitude, so we'll answer the magnitude question here. So the magnitude, pretty straightforward. If I want the horizontal force, this is just the magnitude of the overall force. Oops, I made a mistake here again. Mr. Wells, come on, these should be magnitudes. Times cos theta. So my horizontal force is going to be 150 cos of 40, which will give me 114.9 newtons. To do the vertical force, I'm just going to put it into my formula. So I get here 150 sine of 40 So my vertical force would be 96.4 newtons. So I get rid of therefore statement. Therefore, the magnitude of the horizontal force is 114.9 newtons, and the magnitude of the vertical force is 96.4 newtons. There we go.